For this problem, we have a concrete plate with a steel pipe buried underground, and we need to consider all forms of heat transfer in order to find the depth of the pipe required. So we begin by calculating our radiative heat transfer, and then we can move on to our convective heat transfer, and we calculate the Rayleigh number and the Nusselt number to arrive at H, and then calculate our heat. And now with our difference of Q required, we can calculate our conductive heat, and then using our resistance network where we have a cylindrical pipe, a ground, and a Cartesian plate, we can back out all of our resistances and get a final transfer coefficient. And then we can determine our pipe depth using S factor. So we hit on conduction, convection, radiation, our resistance network, and we have both Cartesian and cylindrical coordinates with natural convection thrown in as well. For our second problem, we have two objects being cooked, so we're going to consider our transient heat transfer. So we first decide if lump sum analysis is valid. We get a BO number that's much greater than 0.1, so it would not be valid. We calculate the time required to compare to our actual time required for the sphere. And once we walk through the 1D spherical calculation, we get a time there. And then for our cylinder, we need to consider the product solution of a cylinder and a plane wall. So we have to do basically everything twice. And then we get a nice expression at the end where we use the product properties to solve for our time. And we can get all of our final times. So here we cover all three forms of transient heat transfer, and we can consider the spherical coordinate system when we consider the meatball.